So in the last class, we have written stimulus program, right? So based upon that stimulus program, brightness increase ಮಾಡ್ರೋ brightness ಕೊಡಲ್ವಾ Okay, so last class we have done stimulus program. So if you open the book, so I'll just explain once again the stimulus program. So in which we have instantiated the main design of ripple carry counter. So module followed by stimulus program. Then we have defined. So you don't look at me, you don't look at the word or the program. So module stimulus followed by initial capacities, nothing will be there because it is a vanilla program without any terminals. So since it is a stimulus program, we don't have any terminals list associated, so we are not going to write anything within the bracket. So followed by that we have seen that the inputs are declared as registers and outputs are declared as a wire. So in the main module program only, whatever the inputs are there, they are defined in the stimulus program as a register, and in the main module program or the design block, so you will be having outputs which will be defined as a wires declaration in the stimulus program. So followed by that, so we are going to instantiate the main design block. So you can see, so we are going to call the program for which you are going to write the stimulus, that is ripple carry counter, followed by that the module name, the instance name, followed by output and input terminal this we have written. So that is the initial part of the stimulus program. You have to write without any doubt. You should write all these things. So first four things you should do as it is. So next is what ripple carry counter main program we have written. So in the design block of ripple carry counter was there, it was instantiating the T blocks, so T flip flop, so T flip flop, D and inverter. So this is the main design block. So for that design block, we have to write the stimulus program is. So it is dependent upon clock is one of the input signal. So always you should write clock is equal to 1 tick bit 0, clock is equal to 1 tick bit 1 marker. So you have to write whenever you want to write in the stimulus program. So that will be very big and time consuming, and it will be a not a good thing to write in the program. So defining the variable. So what I am going to do is, so the clock signal will be defined as a program. So that means we are generating a clock. So clock is assigned as one register. So clock is equal to 1 tick bit 0 on the initial begin and the value. So you can see initial clock is equal to 1 tick bit 0. It is there. So I have also told the importance of initial. Whenever initial program is being called in this one, so that is also one of the keyword. So initial, whenever it is there in the program, so it is going to start from the beginning of the simulation time. So it is going to execute those statements within the initial block. So within the initial block, all the statements will be there. Whatever the statements is there, so it is going to execute from the 0 level setting. So followed by that, it is going to execute the line clock is equal to 1 tick bit 0. So it is the initial assignment for clock signal as 0 I have given. So whenever I have given that 0, so you should tell your teacher to rub the ball. Whether I rub or not. If I don't rub, I make others to rub. So clock value, see listen, the clock value initial time of the waveform cell, right? You can see. So this is how the simulation program is going to work. So clock signal will be starting at 0. So at this time in nanosecond, at 0 time, so the clock value is 0. 0 time, the value of ascent is 0. So next line which we have written is always. So always at the rate. So always is also one of the important keyword. So the name itself it is showing always means so it is going to check execute this the next line of the statement after the always, that is always hash by clock is equal to tilde of clock. So that means this line it will start from initial clock is equal to 1 tick bit 0 and then it is going to execute the always statement. So first it will execute this, so next value it is going to assign this, it will execute. Next line when it comes it is going to be the always statement. So whatever there it is there in the always, so it is going to run till you finish the simulation. So in order to finish the simulation we are going to use $finish. So till it line gets executed, till this line gets executed, so this will be executing. So here what the importance of this line is, hash 5 is nothing but 5 nanosecond delay. So the value of the initial value is 0. After 5 nanosecond, the clock value is going to change. Negation of clock at the continuum. So this indicates what? Clock is initially it is 0. Now it will after 5 nanosecond it will come to 1. So that is what we are going to generate the clock. So this is going to retain up to 5 nanosecond again, and then again it will come and 5 nanosecond again it will be there. 5 nanosecond come down. So till you run the simulation, so it is going to generate by itself. So this is the importance of clock. Why clock is important? Because your ripple carry counter, it will depend upon the negative edge of the signal. So whenever the negative edge of the signal of the clock will come, at that instant the module of the main module program is going to change the output. So output is going to vary because of negative edge of the trigger. So for that purpose we need to generate a clock. So this is the clock generation. So this is one part of the stimulus. So this is one statement which has been executed. So forget about this. So it is going to always it is going to monitor, always it is going to the clock value will be toggling for every 5 nanosecond. So this is first part of clock generation. So next is what? So in the ripple carry counter, clock is one input, reset is another input. So reset, I can, whenever the reset for 4-bit ripple carry counter is there, so you can see 4-bit ripple carry counter. So this is one clock signal. So that clock signal I have generated here, and another one is a reset signal. So this reset signal I can give because it is also stored as a register value, so I can change the value. So based on that I can see reset like this. I can give any runtime, simulation time, I can give the assign the value for the reset and I can change. So next program which will be there inside this is the initial, then followed by that reset is equal to 1 tick bit 1. So here they have given. You can see the next initial block, it is there. So in that initial block, so double line, double backslash is a single line comment. Okay, so double backslash in any program if you are having, then the simulator will be treating it as a comment. So whatever first two lines it is there, so it is nothing but a comments. So next is initial. So after initial begin, so you can see this is the keyword. So reset value is being 1. So it will be at the initial statement itself. The reset value will be in 1. So you can see this is 1 logic 1 state. So whenever reset is high, the program or D will come, it is going to work. So it will be working when there also you can see always at the rate within the bracket what it has been written, positive edge of the reset or negative edge of the clock. So here you can see there is a positive edge at the 0 nanosecond itself. So here the positive edge of the reset is there. So your output Q will be of 4-bit value. So it will be 0. See why I am explaining this again. I don't have time on the lab. So I will be giving now the next assignment. So next assignment so you have to do in this one. So ripple carry adder I will be giving. I will give the waveform and you have to write the similar code for that. For that reason I am explaining once again. It is very important. So initial begin reset is equal to 1 tick bit 1. So that is means what? So the value of the reset, since there is no delay, I have not written any hash. So the reset value will be 1 at 0 nanosecond itself. If I am not writing any value with the hash, so we are not going to give any delay over here. So it is going to start at the 0 nanosecond itself. So after that, what I have written? Hash 15 reset value will be equal to 0 by the program. So you can see on the board hash 15 reset value is 0. So that means 5, 10, 15. So at this instant the value of the reset is going to be 0. 1 tick bit 0. So previously it was 1 tick bit 1. So 1 means what? The number of bits. So reset is of 1 bit. So 1 tick bit 1. 1 tick bit 0. So the value of the reset I am going to change in my program as 0 after 15 nanosecond delay. So here what does this indicates is initially it is 0 nanosecond, it is going to start the simulation. So after 15 nanosecond delay the value is changed to modified to reset is equal to 1 tick bit 0. So whenever the reset value comes down, so I am not changing, and till that time the value of the Q will be equal to 0, 0, 0, 0, 0 or decimal 0. So in the bracket I have written the decimal, there they have I will show the figure. So the waveform, so there it is written in 0. So idamele ಏನು ಮಾಡುತ್ತೆ? So reset is come down, so it will be monitoring the next negative of the signal, clock signal. So whenever the negative edge of the clock signal arrives, you can see the Q value will be Q of 0, Q of 1, Q of 2, Q of 3. So this is nothing but decimal 1. So the value has been incremented by 1 because it is the first clock signal and the previous clock signal Q was 0. So through the inverter D was having input as 1. So negative edge whenever it comes the next clock cycle, so it is going to increment the value by 1. So next thing is, since the reset value is still low, so in the next edge of the negative edge of the clock signal, again the value of Q will, first output of the Q will be 0 because the clock is changing. So here we will be having 0, 0, 1, 0. So this will be happening for every 5 nanosecond. For every negative edge of the clock signal, you can see there is increment, there is toggling. You can observe in the case of the lower order bit. But whenever there is a high to low transition, so here you can see this is high to low transition. you can see that will be acting as a clock signal for the second D flip flop. So at that instant the next output Q of 1 will be changing to its state. So now next the clock signal it will be 0 0 1, it will be same because 0 to 1 transition it is not going to affect this output. Correct? So whenever this goes 1 to 0, in the next case 0 0 1 0 0. So ಇಲ್ಲಿ 1 ಇಂದ 0 transition ಆದಾಗ so here also it will go to 0 1 to 0 transition ಆದಾಗ so it will act as a clock for the third. So you are getting this as a output. So like this it will keep on increment as long as the reset pin is low. So it will increment how many times? So 1 1 1 1 takam aadmele. So again if the reset pin is not high, so it will be output, the next state will be 0 0 0 0 because why? At that instant all the flip flop states will be having 1 to 0 transition, so it will be changing the state as 0 0 0 0. So I have written this test bench and already shown the output. So in this the third block here I am going to use a special case, so wherein which you can get the text output. Okay, so this is the text type of output we will be getting. So in order to get the text type of output, you are going to have in the C program like printf. So printf on the statement use ಮಾಡ್ಬಿಟ್ಟು so the output of the sum of A and B is ಅಂತ ಹೇಳ್ಬಿಟ್ಟು so you are going to write what is the output Q ಅಂತ ಬರೆದ್ರೆ so you are getting the printf statement and output of sum of A plus B is 15. Like that you will be getting as a output statement. The same way here you are going to get the output statement in Verilog by using $display or $monitor. So dollar is nothing but a system task. So that is a task that will be given by us for the system, that is Verilog simulator, to perform certain output display. So here I am going to use one system task as $time. So during from the 0 initial statement, that is going to start from 0 nanosecond. So it is going to monitor. So here the name itself is nothing but monitor. Monitor means what? Monitoring means what? So monitoring means if there is any changes happening, so it has to give the at what time the changes happen and what is the change in the output. So changes happening is nothing but monitoring of output. So output whenever it gets changes. So you can see here the output is changing at 0000 in the so 0001. That means output has shifted. That is it has incremented count. So that is nothing but it has changed its state. So you can see whenever there is any changes. So during every negative edge of the clock cycle, you can see there is increment in the output. So that is nothing but for every 10 nanosecond, you will be getting the output and it will be being monitored. And you will be getting this as the output. So at the initial time 0, the output was changing. So initially the output was 0 0 0 0. So it is getting like that. So after that what is happening? Up to 5, 10, 15 nanoseconds, since the reset pin is high and the output is not changing during this time 0 to 15 nanosecond. So you are not getting any output over there. So output will get what? So it will be getting as negative edge after 5 nanoseconds. That means 0 only change the output now. The next output is getting changed at 20 nanoseconds. So it is going to display the corresponding display time at which the $time, using the $time, it is displaying at what time the output Q is changing. So it is going to give the timestamp for every change in the output. It is being monitored and this is what you are going to get the output. This is the ripple carry counter stimulus block. Ivaga, any doubt is there, you can ask. Otherwise, I will give another simple Verilog program which you are already familiar. So to write a program for design of ripple carry adder, 4-bit ripple carry adder for So using the top down methodology, so four bit ripple carry adder. So this 4-bit triple carry counter, how it has written? So from the top down design methodology we have written the program. So first was triple carry counter. It is divided into how many blocks? 4 T flip-flop blocks. And each T flip-flop is having D flip-flop and inverter. So further we are not going to divide. So like that only now you perform the 4-bit triple carry adder, 4-bit triple carry adder. So very much we will be having how many inputs? A, B, C. What is the input size of A? A is of how many bits? B is of how many bits? Four bit triple carry adder. 4 bits से करने हैं. A is of 4 bits, B is of 4 bits, sum is of 4 bits, C out is 1 bit, C in is 1 bit. A 4 down to 0, 3 down to 0. How I can divide this triple carry adder? This is the top level block. So now, if I want to divide this 4-bit triple carry adder, how I can divide? There is Disha. First pattern put करने देना. 4-bit triple carry adder. 4 So 4-bit triple carry adder is divided into 4 full adder blocks. So this 4 full adder again I can divide into 2 half adders. So here also 2 half adders. Half adder cannot be reduced further. Simpler. So this is what the top down design methodology. So now write this program of 4-bit triple carry adder. Design block address simpler. document का लगा कितना लगेगा you have to write the design block. How many programs you have to write? See whether internal service postponed 100%. Huh? Yellow. What's the name? Smoke. Postponed like that. Announce ಮಾಡಿದ್ದಾರೆ 14th. CRA. Meeting ಎಲ್ಲಿ How to begin with? Module? Triple carry adder? Top level, top to down approach. Module triple carry adder followed by next output sum correct next correct block ಕೊಡಬೇಕಾ ಯಾರು block ಎಲ್ಲಿ ಕೊಟ್ಟಿದ್ದೀನಿ block C ಅಂತಾನೆ ಕೊಟ್ಟಿರೋದು output is of how many bits 4 bits See, whenever you see this one, here no need to define. Here I am defining vector notation 3 down to 0, a of 3, a of 2, a of 1, a naught, b of 3, b of 2, b of 1, b naught. C is a single bit and C out is of single bit output. Next. Next step ಬರೀಬೇಕು wire ಯಾವ wire next single bit as not having any vector. Hey, first ಏನು ಬರೀತಿದ್ದೀನಿ ಪ್ರೋಗ್ರಾಮ್ ಅದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ ಒಂದು ಫುಲ್ ಆಡರ್ ಇನ್ಪುಟ್ ಏನಿರುತ್ತೆ ಎ ಬಿ ಸಿ ಇನ್ ಸಮ್ ಅಂಡ್ ಸಿ ಔಟ್ ಎ ಬಿ ಸಿ ಇನ್ ಫಸ್ಟ್ ಫುಲ್ ಆಡರ್ ಮಾತ್ರ ಸಿ ಇನ್ ಬರುತ್ತೆ. ರಿಮೈನಿಂಗ್ ಆಲ್ it is defined as while. So output is sum of 0. C of 0 is the internal output while. So here I am going to define 2 down to 0 C. Don't get confused. C of 2, C of 1, C naught. So C naught is the output carry. Sum of 0 is the output. A of 0, B of 0, C in is the input. So next one is what is the output? This C of 0 acting as a carry. C of 0. So these two along with the previous carry of this acting as a input for this second full adder. Sum of Ileno. Sum of 3, comma after this now next ಇದು ಅರ್ಥ ಆಯ್ತಾ? Next, when I try to execute this, whether it is going to work, it is a top module. So it will invoke this full-level program. So next I should write top module. ಹಂಗೆ ಕೊಡಬೇಕು ಅಂತ ಏನಿಲ್ಲ. See the same thing you should give ಅಂತ ಏನಿಲ್ಲ. ಹೋಗಿ next I should write any changes. 3 down to 0 ಬರಬೇಕಾ? ಅದಕ್ಕೆ ನಿಮಗೆ ಹೇಳೋದು ಬರಬೇಕಲ್ಲ. ಇದು ನಿಮ್ಮ ಕೈಯಲ್ಲಿ ಮಾಡಿಸ್ತಾ ಇರೋದು. ಅಕ್ಷಯ್ಗೆ ಮತ್ತೆ ಈ ಕಡೆ ನಾನು ಮಾಡಿಸಲ್ಲ ಪ್ರೋಗ್ರಾಮ್. ನನಗೆ ಹೇಳಿದ್ದೀನಿ, ಕೊಟ್ಟಿದ್ದೀನಿ ಅಸೈನ್ಮೆಂಟ್, ನೀವು ಮಾಡಬೇಕು ಅಂತ. The same procedure of people carry counter here you have to use ಅಂತ ಹೇಳಿದ್ದೀನಿ. ಬರೀ ನಾವು ನೆಕ್ಸ್ಟ್ how better ಎಷ್ಟಬೇಕು? 2 half. See, the name is different. Here I have written full underscore add. Here also you should use full underscore add only. You should write. Otherwise, it is not going to treat as the same program.
Instead of taking I
am my program. I am given like this. You have to take program. Program ನಂದು ನನಗೆ ಎಷ್ಟು ಬೇಕೋ ಅದೇ ರೀತಿ ಹಾರ್ಡ್ವೇರ್ ಡಿಸ್ಪ್ಲೇ ಮಾಡಿ ಅಂತ ಕೊಟ್ಟಿರೋದು. So this is top down approach. Half adder. ಎಷ್ಟು ಬೇಕು half adder? One full adder using 2 half adders. So ಎಷ್ಟು ಔಟ್ಪುಟ್ ಎಷ್ಟು ಇನ್ಪುಟ್ ಇರುತ್ತೆ?
2 inputs, 2 outputs.
What is the first output? For the first half adder, A and B are the inputs. Sum and carry ಬರುತ್ತಾ? So next half adder ಗೆ ಯಾವುದು ಇನ್ಪುಟ್ ಹೋಗುತ್ತೆ? ಅಖಿಲ್ ರೆಡ್ಡಿ. ಪುನೀತ, ನೀನು ಎಲ್ಲಿ ಕೂತ್ಕೊಂಡಿದ್ದೆ? ಬಾಲ ಒಂದಿಲ್ಲ ಅಷ್ಟೇ ನಿಮಗೆ. ಹೇಳ್ರಿ ಇದು ಆರ್ಗೇಟ್ ಬರುತ್ತಾ? ಕ್ಯಾರಿ ಔಟ್ ಎಲ್ಲಿ ಹೋಗುತ್ತೆ? ನನಗೆ ಗೊತ್ತಿಲ್ಲ. ಒನ್ ಫುಲ್ ಆಡರ್ ಇಂದ ಎಷ್ಟು ಮ್ಯೂಸಿಕ್, 2 ಹಾಫ್ ಆಡರ್ಸ್ ಹೆಂಗ್ ಗೊತ್ತಾಗುತ್ತೆ? ಅದಿಲ್ಲಿ I know this inside. This is I know. Some minute complete ಆಗಿಲ್ಲಲ್ಲ ಕ್ಯಾರಿ ಎಲ್ಲಿದೆ ಸೊ ಇಲ್ಲಿ ಫೈನಲ್ ಸಮ್ ಬರುತ್ತೆ so this C out will get add with this ದೇವಿಕಾ ಹೇಳ್ರಿ ನಿಮ್ಮ ನಾಲ್ಕು ದಿನದಲ್ಲಿ one full adder relation is to half adder one full adder realized full adder using two half adders paper ತಗೊಳ್ಳಿ ಪೇಸ್ಟ್ ಪೇಪರ್ ತಗೊಳ್ಳಿ ಪೇಸ್ಟ್ ಪೇಪರ್ ತಗೊಳ್ಳಿ ಅಂದ್ರೆ full adder using two half adders ನಾಳೆ ಬೆಳಗ್ಗೆ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದೇ ಪ್ರೋಗ್ರಾಮು ಅಲಾಂಗ್ ವಿತ್ ಸ್ಟಿಮ್ಯುಲಸ್ ಪ್ರೋಗ್ರಾಮ್ ನೀವೇ ಬರೀಬೇಕು